Niacin, often dismissed as just another vitamin with broad, nonspecific roles, is now being recognized as a nutrient with remarkable pharmacological precision. Unlike many micronutrients that act diffusely across tissues and systems, niacin targets specific molecular pathways, most notably CD38 and LXRA, with a level of selectivity more commonly associated with engineered pharmaceuticals. This repositioning elevates niacin from a general health supplement to a metabolically intelligent compound that can modulate key aspects of cellular function, inflammation, and lipid homeostasis with minimal off-target effects. One of the most compelling examples of this targeted action is niacin's ability to selectively upregulate CD38 in macrophages under lipid stress. CD38 is a multifunctional enzyme involved in NAD, metabolism, and calcium signaling. Upon niacin administration, CD38 expression rises significantly, leading to increased production of nicotinic acid adenine dinucleotide phosphate, NAP. This second messenger then triggers lysosomal calcium release through TRPML1 channels, an event that activates downstream transcription factors, including LXRA, which governs the expression of cholesterol transporters such as NPC1, ABCA1, and ABCG1. Critically, this entire cascade is not a random, system-wide reaction to niacin, but a focused response that occurs in macrophages under oxidative and lipid-induced stress. The calcium-mediated activation of LXRA and the subsequent mobilization of cholesterol out of lysosomes does not appear to happen in healthy hepatocytes, where synthetic LXR agonists notoriously trigger lipogenesis. This means niacin acts not only at the right molecular targets, but also in the right cellular context. The selectivity of niacin's effects reflects an evolved compatibility with cellular stress-sensing networks. Macrophages overloaded with oxidized LDL generate intracellular conditions that make them uniquely responsive to niacin's signaling effects. These conditions include heightened CD38 expression capacity, increased sensitivity to calcium flux, and reliance on cholesterol efflux mechanisms to maintain homeostasis. Niacin capitalizes on this vulnerability, correcting lipid trafficking dysfunction without altering systemic cholesterol levels or harming other tissues. This targeted mode of action sets niacin apart from many micronutrients, which often exert their effects through cofactor activity or passive nutritional roles. Instead, niacin behaves more like a precision tool, triggering specific signaling pathways that restore balance to cells under duress. This is not just pharmacology via nutrition, it is therapeutically intelligent nutrient signaling. Moreover, the signaling pathways niacin engages are deeply integrated into metabolic resilience. The CD38, NAP, TRPML1 axis not only facilitates lysosomal cholesterol clearance, but also influences mitochondrial function, autophagy, and inflammatory gene expression.
By elevating NAT
availability and modulating calcium flow, niacin supports multiple layers of cellular defense against oxidative damage, lipid toxicity, and metabolic collapse. This multidimensional, yet highly specific profile redefines niacin as more than just a vitamin B3 molecule involved in redox reactions. It is a micronutrient with a capacity to correct pathological intracellular signaling with finesse, targeting immune metabolic dysfunction in atherosclerosis, chronic inflammation, and potentially other degenerative conditions. In summary, niacin exemplifies a new category of precision micronutrients, compounds that operate not by blanketing the body with broad support, but by engaging specific molecular switches within stress cells to restore equilibrium. Its selective activation of CD38 and LXRA and the resulting cascade of protective effects illustrate the powerful potential of nutrients when understood and deployed with scientific depth. Far from being outdated, niacin is a model for how nutritional molecules can achieve pharmaceutical-level impact with remarkable biological intelligence.